Yes. Out of curiosity,
Yes.
I just wanted to ask you that how long have you been switched on your system
Mm.
for getting a result?
Very nice question, because I do not have any system at my home.
Okay, at your place of work.
Yeah. Out of my work, when I was working with Axelis, yes, we have our own server, and we used to run it 24/7/365. So the calculations will be always running. The reason why the calculation was running, we was having service providers. Service provider in the sense, some of the small biotech companies will be not able to buy the tool, which is lakhs and lakhs of rupees. So they just give the compound or give a case study. They'll ask us to do it, and they'll be paying them, which is very nominal and affordable. So since that calculation goes up, they will be giving their own in-house databases. Their in-house databases, for example, Jubilant, Ocimum had in-house databases of chemical compounds, and it's very popular worldwide. But now nothing. So with the chemical in-house databases, they'll be giving us. It will be in 2D format. We need to convert it to 3D. We need to minimize it, generate all the possible conformers, which took basically, I should say, approximate about 3.5 months. Then they gave the target, 4 targets. One target with all the possible conformers. It took again around 4 months nearly. These 4 months, machines were not switched off, and you cannot enter the machine room because the AC, the temperature was like 5-6 degrees, because that much machine heat is being ejected out. So I cannot say that I have spent 4 months on it. Machine was spending 4 months on it. We used to check the log files, whether it is running properly, whether we are getting the properly, any error messages are there. So we will be checking only the log files. So what I have shown in the text mode is a log file. It's not a result. It's just a log file. You will be able to follow up with, to do something, and if any queries or discussions. That is a big applause for me. As I mentioned, it is an interactive session and nobody has interacted, except a guy who was sitting here and finally there. Yes, speak out, please. As I told you earlier, I'm not very master in it. I spent like around 6 years, 6.5 years in it. And still I'll say I know only 0.1% of this particular field. Yet to learn, learning daily, moving on. So whatever it is possible for me to get answered, yes, I will do it. Otherwise, I'll find the results or the answers and get back to you 3 again. So please don't hesitate to ask whatever is in your mind.
So it was really useful session here.
Yeah, yes.
Yeah, okay. So actually I am a fresh guy into the system.
Okay.
Okay, so I have got a lot of questions, and you can expect a lot of questions online. I have noted your email address.
Oh, okay, great.
And the last question.
Yes.
It's a general one.
Okay.
That I have had. I'm having a plan with me, a plan.
Yeah, okay.
Plan. Okay. And I want to test it whether that would heal disease.
You're talking about plant.
Plan. Yeah.
Okay. Okay.
And how can I go about it in terms of this drug design?
Okay. First thing is wet lab. You want to extract, which is the exact protein or the compound that you are looking for. It can be a protein or a chemical compound that I don't know, which you are looking forward. So based upon your plan or based upon the history of, probably it will be a medicinal plant and comes under Ayurveda, might be, I don't know. I'm just telling the possibilities. You need to extract it properly, first thing. Next thing, you need to have a crystallographic structure. For that, you need to crystallize that particular compound, which is feasibly possible in South India. In Madras University, it is possible. If you give the sample, he will crystallize it and give it to you. And in Trivandrum, is it possible or not? I don't know. NIST is having any facility of crystallography? Anybody knows? Anyway, I'm not relevant. So first, you need to have the crystal structure. Once you have the crystal structure, the data is being up into the computational tools. So that's the data. It can be a chemical compound, it can be a protein, whatever it is. I don't know which is the compound that is your focus. X or Y. Once you get the compound, let me say about a medicinal compound, it's a chemical compound. Once you get the compound, you can try it out in the online whether there are any other compounds similar to this. For that you can use a tool, online tool called Chemicalize. Chemicalize. This tool helps you to search the database using the structure itself. Because you have extracted the compound and you do not know what is the name of the compound. You know only the composition and the structure of the compound, being it is crystallized.
This is similar to that of homology mapping in BLAST, say.
Not BLAST, VAST.
BLAST.
In NCBI there is a tool called VAST, V-A-S-T, structural alignment. Somewhat similar to that. But VAST is basically doing PDB, protein structural alignment. Here we need a chemical structural alignment, which is possible in Chemicalize, not in NCBI or any other tool. In PubMed is possible, DrugBank possible, whatever data or the structure is there within the database, that can be compared. But when you are giving your own compound, it cannot be compared with their databases. So that can be done only by Chemicalize. So first process is to find out whether there is any similar compound for them. I am talking about chemical compound. Further, then we need to understand if they are very similar and one of the element is different. Let it be a functional group, let it be a branch or a substructure is different. So you will be trying to say that my compound is having the similar property of the existing compound. Then you will do some property analysis. You predict the descriptors and by which you predict the property of your compound. If you feel that it is having anti-cancer or anti-diabetic, whatever it is, you will try to find out. The next step is you need to have the target. You will be trying in different target because your compound is defined. You know what is your ligand, what is the activity of the ligand. Now you want to know proper target. So you will be finding out a target by docking analysis with different levels of target. Then you need to understand how it is, whether it is stable or not. It can be a good compound, but if it is not stable, how can you use it as a drug? Whether it is deliverable, whether this compound is toxic or not. Whether it can be absorbed properly by our biological system. Whether it can be excreted properly. Whether it is soluble. All these things to be analyzed, then only you can say, and even then you can patent it. Before that, when you extract it and you said that this has this property, yes, you can patent it. I had a collaborative work with one of the institute in Trichy, where they have extracted 7 compounds from medicinal plants, and that plants from hilly regions of ERCAD, and they have directly patented it, and now they are doing computational work on it. Because first come first serve, it's the same strategy for research to patent and publications. You have got the idea, I have copied the idea and I published the paper. You are not considered, I am considered. That's how the strategy is going on. So that's why, so first come first serve, they have already patented it. Now they are doing the computational analysis to understand which target is basically good for this compound. So that's how the whole scenario takes, which is not possible by a single person, which is not possible by a single institute, because our institutes, all institutes are not having fully equipped instruments or equipments to do all these processes. Again, yes.
My interests are in programming side.
Okay.
In designing an algorithm.
Okay.
So right now I have idea about only dynamic algorithms or sequence analysis or sequence kind of thing.
Okay.
So the algorithm and programming regarding drug design. So what parameters should I take into notice if I want to enhance my programming skills, put my programming skills in drug design?
Great question. But first question to you. Since you're asking me question, one more question to you. Have you ever made a research search? What are the programming languages used for structural analysis and visualizations? Yes. So normally we use PHP, .NET in some of the places. I don't know programming very well, but under my experiences, I've used around 7 tools. These all tools I've used Fortran, Perl, Python, with the help of Java for visualization. So I give more importance to Perl and Python. Examples: PyMode, visualization is there, Python. Schrodinger, Python. Discovery Studio, Accelerist, Perl. MOE comes up with a Perl interface, but they have created a new language called as Scientific Vector Language, that is called SVL, that is for MOE. And again for Trimpos, it is Perl. So whatever that is existing, we have seen, even Autodoc also, it's coming under Fortran, and I think Perl also into Perl, or no, Python. Python comes into the picture with MGM. So they are also using Python. So I would prefer Perl and Python. But the thing that is very bad is Perl or Python is not being taught or trained to you by any of the IT trainers here or anywhere. It's very tough to find out. But people are there in some of the places, they are trying to do it. But anywhere I have not seen any of the advertisements regarding Perl and Python. So I would prefer to go look forward Perl and Python, including Java for your visualization capabilities.
Actually, the question arises just after your presentation. The research thing was not done because of that.
Okay.
Because before this drug designing tutorial or your presentation, I wasn't that much into drug designing.
As you were mentioning in the
Yes,
afternoon.
yes,
Yeah. Yes. Anything else? Yes.
Thanks a lot for very lucid and very comprehensive lecture.
Yep.
To be really frank, I probably might not never use drug designing as a study, but there are some groups in our institute which usually work on drug designing, and definitely now at least the terminology won't go over my head.
So may I know from which institute?
I'm from IGID.
Oh, okay, okay.
Thanks.
Yeah, sure. Thank you. Anyone else? Yes.
You are telling about ligand preparation.
Yep.
In every step we are doing the ligand preparation. Is there any database available where already prepared ligands are available?
Yes. CCDC, Cambridge Structural Database, that is Zinc database. ZINC. They are prepared databases. They are prepared and annotated. Anything else? So I think it's time for us to go for a slide or a big dinner. That depends to you. So thanks for listening and having a bit sort of interaction at least at the end of the particular tutorial session. Thank you so much.
Thank you, Mr. Girinath. As a token of appreciation, I kindly request Rajini to present a memento to Mr. Girinath Pilli.
Sir,
Thank you,
I think
Rajini.
you should probably give this boat to your fiancé.